28 years now. It's a lot of fun taking care of patients. I still ride the ambulance, I ride the fire truck, and a bunch of different stuff like that. So it's a lot of fun, but it's an honor to be able to be here and talk to you guys about oxygen therapy for patients. It's really not anything you need to be afraid of or nervous about or anything like that, because as long as you understand a couple of little caveats, a couple of little concerns and stuff like that, you can't really pose a danger to yourself or to the patient, because everybody needs oxygen to live. But let's move over here, and I'll start talking about the tanks and a little bit of what I know about the tanks and some concerns and stuff, and I'll show you how to put the regulator and the tank together. Then I'll cover some of the devices that you can actually apply to a patient and how they need to be set up, and then how to actually apply them to a patient and what to look for. Okay, so we'll come step over here. This is tanks come in all sizes, but one thing I wanted to point out right here, if you look, and I'm going to hold this one, but if you look at this tank in my right hand and you look at this tank right here in my left hand, you notice that this one's aluminum and this one's steel. This one is much heavier. The tanks are pressure vessels, and so they have to be hydro tested every so often. What a hydro test is it's the place that fills these up with gas. They take them and they have to test them every couple of years. For steel, it's every 5 years, because steel's very strong. It can go a long time. But the steel tanks need to be hydro tested every 5 years. The aluminum tanks are still strong, but not as strong as steel, and they need to be tested every 3 years. And what I mean by hydro test is they'll actually take the tank, they'll unscrew the neck, the valve of the tank, and they'll fill it with water. That's hence the hydro. They'll fill it with water, and they'll pressurize it. A normal tank will hold about 2,000 pounds per square inch of pressure. Okay, and so it's a bomb, but don't worry, it's not going to blow up on you. and they'll fill it up with water, and they'll pressurize it to like up to 3 times what it's normally rated to hold. And they look for deformation of the body or anything like that to see if there's any bubbles coming out, anything like that. And then they'll take it out of service, and it's no good. So you can always rest assured, as long the tanks have to be hydro tested frequently, and every 5 years for steel, every 3 years for aluminum, and that ensures the tank integrity. It's not going to blow up on you or anything. Okay. So the other thing I want to talk about, if you notice, I got my hand on this thing. I won't let go of it. If it's not in a holder, I'm just talking about concerns and stuff like that. If it's not in a holding device that keeps it stable, don't let go of it. Okay. Either don't leave it on a table or anything like that. What you want to do is you want to protect this screw-in neck from breaking off, because if this breaks off, it becomes a rocket ship, and it can go through a wall. It really can. It can go through a wall. It can break legs, break arms, hit you in the head. Those kind of bounce all over the place, that kind of thing. So it's just, anytime you're carrying these things, we always protect the neck. We don't want to drop it. So it's okay to lay it on the floor. In fact, we do all the time in EMS. It's okay to lay it on the ground that way, because it can't fall down. Okay, it's not going to fall down. But this is dangerous, because if it gets knocked over and this top neck part gets knocked off, and it can, then it becomes a rocket. All that 2,000 pounds of pressure starts coming out of this neck like rocket thrust, and it takes off. Okay, so just be concerned about protecting the neck. All right. Let me set this back up here. Actually, I'm going to set it on the floor. Let me talk a little bit about the tank itself. If you look at these tanks, how do I know it's oxygen?
Green.
It's green. That's one way, because these are standardized industry colors. Okay, so I know it's oxygen because it's green, or if you look at this one, green and silver. And what's another way? It says oxygen on the label. It'll say oxygen USP, so it's classified as a drug. So it's green and it says oxygen. Do y'all know what these holes mean? Okay, this is called a pin index safety system. So oxygen tanks are not the only type of tanks that exist in the world. You have acetylene tanks for torches. You have oxyacetylene tanks that for cutting torches. You can have nitrous oxide tanks. You can have helium tanks for filling up balloons. Blah, 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 blah. So you can have all kinds of, but only oxygen is good for putting into people. And these holes right here, these two little holes right here, okay, this hole, this big hole right here is where the oxygen comes out of the tank and it comes out of this hole. This little valve right here, I'm going to turn it ever so slowly, but y'all know how you put on a bottle cap on a soda pop bottle? Righty-tighty to close it, lefty-loosey to open it, okay? So the wrenches are pretty standardized. They come in different sizes. This one's a flat one. This one's a little bit nicer, but it has the little square holes in it that fit right on top of that valve. So righty-tighty closes it, so it's closed right now. But if I turn it ever so slightly lefty-loosey to open it, and I'm going to point this hole in a safe direction because sometimes rust and stuff like particles can come shooting out of it. But if I turn it left, you'll hear the air come out. Oh, this one's empty. Stand by. Switch tanks here. Here's the same holes, okay? Here's the air comes out hole. This is the valve. If I open it slightly, you're gonna hear the air come out. Okay, now if I open it up a lot more comes out. 2,000 pounds of pressure. Okay, there's a whole lot of pressure in there. So, first of all, so now that you see the parts, this is the valve that screws down righty-tighty to close it, lefty-loosey to open it. This is the key. This big hole is the hole that the oxygen comes out of. These two little holes here, what are they? They're pin index holes. The whole gas industry, oxygen, acetylene, helium, the whole gas industry has what's called a pin index safety system. And what that does is they have a series of, I think it's 7 holes. They have a series of 7 holes. It looks kind of like a smiley face. They might have 2 holes here. They might have 2 holes here. They might have a hole down low and a hole up high. However they have it. The regulators, if you look inside an oxygen regulator, all regulators that fit on an oxygen tank will have 2 little pins. These are the index holes. These are the index pins right here. And they're set in exactly the same configuration as the holes. And in that way, it only allows an oxygen regulator to go on an oxygen tank. You can't put an oxygen regulator on a helium tank. You can't put it on an acetylene tank. You can't put it on any other kind of tank. An oxygen regulator will only fit on an oxygen tank, and an acetylene regulator will only fit on an acetylene tank because their pin index holes and pins are coded to that type of gas. Does that make sense? That prevents an accident of hooking up an oxygen regulator to an acetylene cutting torch and running acetylene through a mask to a patient and killing them. That's a safety design. Does that make sense? Okay. So that also helps you align up the regulator. So I have this tank full of air, full of oxygen, and I need to get it to my patient. Most of the times these things are already built, but just so that you understand how they're put together so you can troubleshoot it. You understand the pin index holes, you understand the hole that the oxygen comes out of, you understand how to work the valve, okay? This is way too much oxygen at this pressure to put into somebody's lungs because you blow them up like a balloon and pop them. So you have to have a regulator. The regulator's job is to step down, it's a 2-part job, to step down the pressure from full-on tank pressure into a kinder, gentler pressure that can go into a human being and not blow up their lungs, okay? So in order to assemble this, if you look at the regulator, let me show you the regulator parts and pieces real quick. I want to set this down. Just safe. If you look at the regulator, okay, if you look inside, what are these called?
Index.
The pins. Yeah, the pin index, the safety pins, and then the holes are the holes that they go in. And then you remember that third hole, that big hole that the oxygen comes out of the tank? Do you all see that big hole right there? Inside the regulator right there? It goes into there. Inside the body of this regulator, from here where the tank pressure goes in at high pressure to over here, the Christmas tree, where the oxygen comes out at a kinder, gentler pressure to go to the patient, in between here is the regulator body, and that's what steps down the pressure. Okay, there's some springs and diaphragms and stuff in there. If you take it apart, all kinds of stuff comes popping out, so don't take them apart. But that's what happens inside here. The other things that it tells you, the two other things that it tells you is right here on this gauge, it will tell you how much pressure is in the tank. Inside this main gauge right here, it'll tell you how much pressure is inside the tank. Do anybody know what it's graduated in? PSI, pounds per square inch. Okay, so that's pounds of pressure per square inch of surface area. So if I draw a little square inch right here, ding, 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 that's about a square inch. And this tank is full at 2,000 PSI, 2,000 pounds per square inch. That's 2,000 pounds of force on every square inch of that inside of that bottle. That's a lot of square inches. 2,000 pounds is a lot of pressure. We can't make that ourselves, so it's a lot of pressure. So this gauge will tell you if the tank is empty or how much it has in it, and it's in PSI. And if you look closely at the graduations, I think they're graduated in 50, hundreds. So you can't say it has 206 pounds of pressure in there. You can't read that good on a gauge. You can only say it has 200 pounds or 300 pounds or 800 pounds. You can only give it in even hundreds, because if you look at the gauge, that's all it's marked in. Okay, it'll have hack, like a watch, hack, 500, 0, hack, 500, hack, 1,000, 1,500. So each of those little lines is 100 pounds. Okay. And then the last thing it tells you, right here on this little indicator, here's a knob. Okay, and that knob will change the number here. And what this is how much kinder, gentler pressure dose of oxygen comes out of this Christmas tree and goes off to the patient. So this is kind of like the dose wheel or the dose knob, because oxygen is a drug. 100% pure oxygen is classified as a drug, and it's dosed to patients in liters per minute. So y'all seen a little 500 milliliter water bottle? You know how big a little 500 milliliter water bottle is, okay? That's half a liter. So 2 of those is 1 liter, and that's how much volume, container capacity volume, 1 liter of oxygen, when you set it at 1, comes out of this little hole. If you set it to 2 liters per minute, twice that amount comes out here. If you set it to 10 liters, okay, that's like 5 2-liter Coke bottles. Does that make sense? About that much air flows out of here every minute. So it's liters per minute is what you dose oxygen at. And it comes out of this little Christmas tree that we bought right here. Okay, makes sense? So the last thing I want to talk to you about on the tank is when we hook these two together. Oh, let me show you 2 more things on the back side. So you saw the 3 holes here, the alignment holes, the safety pins and the safety pin alignment holes, and then the main hole that the oxygen comes out of. If you look at the back side, you have a big round piece right here and a little indentation right here. That little indentation is just where the screw wheel screws into to grab onto this and tighten it. Okay. That little hole right there, or what this is a metal disc. It's called a burst disc. In the fire service and the EMS, sometimes we refill our own bottles because we'll have these big, gigantic M cylinder bottles. 'Cause these things come in all sizes, but we'll have these big ones that stand about as tall as a person, and we'll have them cascaded. We'll have a high pressure, a medium pressure, and a low pressure, and we'll have some wires and some lines and valves, and we'll fill our own little bottles back up to 2,000. This disc right here is called a burst disc. It's to protect the bottle from exploding. If you over pressurize this, if you mess up and you over pressurize this beyond, say, anything north of 2,000 pounds, this little disc right here will pop out, and then you'll get just a constant like that, because this is a direct hole into the tank, and the burst disc bursts and lets the pressure off, thereby preventing an accidental explosion, a failure of the tank and an explosion. Because this going off if you search the internet, you can probably find pictures of failed oxygen tanks, and they'll blow the cabinet and doors off of a fire truck. The fire truck's made out of a big chunk of metal and stuff like that, and they'll blow the cabinet apart on the inside and destroy everything in it, blow the door off. The door will be on the other side of the station or out in the yard or something like that. Those kind of things have happened. Very rare, but that burst disc is supposed to pop out and not let the tank get over pressurized. So that's another safety measure. Make sense? Okay, so to put this together, do you understand? I take the alignment pins and I have to line them up with the alignment holes, okay? And then that third little hole up here has got to line up with this hole. So this part of the apparatus comes in and mates up with this part of the tank. But you understand that metal on metal is not going to seal good? You got to have some kind of rubber or some kind of seal or something in there, because metal on metal is going to leak. You can't ever get it tight enough to make it not leak. That's what this little doohickey's for. These come with all brand new oxygen tanks, and you should always have some laying around close to your oxygen tank. These are the little seals that seal up right here at the big hole between the metal of the valve and the metal of the regulator. So you have to install this first. When we have students and they put these together and they have a leak, we're like, think it through. You have a leak. Why do you have a leak? And they think it through and they're like, metal on metal. I don't have a seal in there. The leak. The answer is not to crank down on these things and get it more tight. You can't. Don't do that. You should be able to adjust all these things with the strength of your hand. Okay. If you have to use a tool or something, something's wrong. You need to troubleshoot it and see why. So I'm going to install the O-ring inside the regulator, just like that. So it's on this big part here. I'm going to align the alignment pins with the alignment holes and mate it up. Yes, get down in the holes. See how it goes in like that? Just like that. And then I'm going to screw this part tight. Turn it around. Just hand tight. Listen. That's it. Do not get a tool and stick it in here, or get pliers or mount this around. You'll destroy your equipment. This is soft aluminum, and it'll deform and you'll mess it up. Then I'm going to turn my gauge in a safe direction, so if it decides to fail, it doesn't blow into my eyes. Set the key on top of the valve. Which way do I turn? Righty tighty or lefty loosey? Lefty loosey. So I'll turn it. Listen. Did you hear it pop? So 1 or 2 turns is all you need. And if you look at the gauge, I've got pressure. Let me get my eyeballs on. I'm at the 5, 6, looks like about 600 pounds. That little black, about 600 psi, pounds per square inch. That's all I've got here is about 600. So this is closer to empty than it is full, because the full one will be about 2,000. All right. And then if I turn it on, say I turn my dosing wheel to 4, that means what? 4 what is coming out of here going to the patient? Liters per minute of time. 4 liters every minute of time. Comes out of this little, and you see how see how that's not like it was? This is kinder, gentler pressure. I could stop it with my finger because it's not that much pressure. It's not, my finger couldn't stop 600 pounds. 600 pounds is on the other side of this regulator. I can stop it, but 4 liters of oxygen flow through that Christmas tree every minute of time. And it'll go up high. Let's see. It'll go up to 20 liters per minute. All right, so this regulator is charged. Before I move on to patience, that's the last part, okay? Let me tear this completely down so that you can see how it tears down, okay? So I've got pressure coming out of this tank. This valve's on. I've got pressure coming out of this tank all the way up to this gauge, right? So I've got pressure